All right, so this is the voltaic cell experiment. Let's go through what the materials are here. This is the voltmeter here. We're going to set that for measuring potential difference in volts. There's the red wire that will attach to the positive terminal on a cell or battery, and the black wire that will attach to the negative terminal on the cell or battery. These are film canisters we're going to use. There's a film canister holder so that they don't tip over. This is acetic acid that we're going to add to those film canisters. Squares of paper that we're going to put down inside the voltaic cells as we make them. This is rods of graphite and some zinc-coated nails. And then these are wires that we're going to use to connect the cells together to form the batteries. So now we're going to start experiment 1, testing the potential difference of the cells in series. Step 1 says set the multimeter to DC volts and connect the red and black electrodes to each other. And that's going to be our data for the potential difference for 0 cells. Okay. Step 2, measure the potential difference and record the data. Step 3, set the multimeter to DC volts and measure the potential difference of a single cell by connecting the red electrode to the positive terminal, the graphite, and the black electrode to the negative terminal, the nail, and record in the data table. So there's the potential difference of 1 voltaic cell. Next, connect 2 cells in series to form a battery. And we'll do that by connecting the nail on one cell to the graphite on the next cell. And then this is the positive terminal of this 2-cell battery, and this is the negative terminal of that 2-cell battery. And we're going to make sure we get a nice stable number from this. There we go. There is the potential difference for a 2-cell series battery. The next step, measure the potential difference of this 2-cell series battery, record in the data table. Next, connect 3 cells in series and measure the potential difference. So again, connecting the negative nail on one cell to the positive graphite on the next cell. And then this is the positive terminal of this 3-cell battery. And this is the negative terminal for this 3-cell battery. And okay. All right, so there's the potential difference for this 3-cell series battery. Next, connect 4 cells in series and measure the potential difference and record in the data table. So again, connecting the nail on one cell to the graphite on the next cell. This is the positive terminal of this 4-cell series battery, and this is the negative terminal for this 4-cell series battery. And there's the potential difference for 4 cells in series. Now we're going to do experiment 2, testing the potential difference of the cells in parallel. Leave the multimeter set to DC volts and connect the red and black electrodes to each other, and that will give us the potential difference for 0 cells. Measure the potential difference and record in the data table. Next, set the multimeter to DC volts and measure the potential difference of a single cell by connecting the red electrode to the positive terminal, the graphite, and the black electrode to the negative terminal, the nail, and record that in the data table. So there's the potential difference for 1 cell. Next, connect 2 cells in parallel to form a battery. We have a diagram that shows how to set up 2 cells in parallel. So we're going to do that now, and that involves connecting the negative terminal of one battery, one cell, to the negative terminal of the next cell, and the positive terminal of one cell to the positive terminal of the next cell. And that gives us our 2-cell parallel battery. Measure the potential difference of this 2-cell parallel battery, and that's on the meter right now, and record in the data table. Next, we're going to connect 3 cells in parallel and measure the potential difference. So that means connecting the negative terminal to the negative terminal and the positive terminal to the positive terminal. So that's our 3-cell parallel battery. Record that in the data table, and then connect 4 cells in parallel and measure the potential difference. So again, positive to positive and negative to negative, and that will give us our value for a 4-cell parallel battery.